C and the blank. But the nutrients breaks down into 6 main categories. And these first 3, I kind of put them in different boxes. They're not super different, but these first 3 are in different boxes because these are the 3 major nutrient categories. But as far as nutrients goes, first you have these carbohydrates. You primarily get these from like plants or milk and that kind of stuff. The lipids you mainly get, you can get saturated, you get from animals, unsaturated you get from plants. The third major source are proteins, and proteins you get from plants and animals. Primarily we get most of our protein from animals. Unless you're vegetarian, then it'll be primarily plants. And then the other 3 forms of nutrients, you have water, which acts as like a solvent, reactant, temperature regulator. It has a number of different functions. Water is very important. Then we have vitamins, which are organic molecules that the body can't make. So we need it for metabolism, but we have to consume it. We can't make our own vitamins. And this last type of nutrient is our minerals. And these minerals are necessary inorganic elements. They're very small molecules, and they're used for primarily 3 main things. The first one is going to be they're used as essential portions of larger molecules. So these minerals are used to make larger molecules. Same goes for ions, and they're also important for mineralizing different things like bone. But that is pretty much the introduction. These are your 6 main nutrient categories. And then we get into, I put in a little picture. I'm going to switch to this blank here. Bring this down. So this shows we have 2 terms. The first one is catabolism, and that is breaking down. And then we have anabolism, and that is pretty much building up. So in terms of molecules, when you have smaller molecules and you use energy to make a larger molecule, that is going to be known as anabolism. Right, so anabolism and catabolism that you see here, it's really just the opposite process. These are just switched. You could also look at just this image and flip the arrow and say you start with the larger molecule and then it goes to energy in smaller molecules. So it's important to note with this building up of the larger molecules, starting from smaller to larger, it requires energy. This is an endergonic reaction, so it's going to take in energy. And that's what really drives these. So you can't make these bonds, build these molecules up without consuming energy, something to actually start this process. Most reactions really require energy to at least get them started, to boost them. You'll have these, I'm going to put this in, catabolism, this is that second one. This is a breaking down, this is a second image here. And that, it does require a little bit of energy to start. It is a reaction that takes place. But the reason why you're releasing energy here is because it's known as like an exothermic. So you're going to produce a lot more energy by breaking this large molecule down. So it's like you have, like you start off like this is your energy level here. And then after you've broken that molecule, the amount of energy that's like dispensed or like comes out of that breaking of the molecule rises up to here. That means that it's like exothermic, you're producing that energy, it's being released from all of those bonds. So that is pretty much anabolism, catabolism.